What's up, everyone? Something that machine learning practitioners do all the time is calculate the mean of a matrix across different axes. And since this operation is so widely used, it has become a very common machine learning coding problem, which you just have to master. Because honestly, if you can't ace this easy problem, it will be pretty embarrassing and you will almost certainly get a fail. So today we're going to do just that and solve problem number 4 here. Calculate mean by row or column. And in this video, I'm going to show you a simple and straightforward solution, which you can use just right out of the box in your next job interview or exam. So if you're new here, in this series, I show you how to solve key machine learning coding problems. And we're going to use deepen.com, which is a great website with lots of good machine learning coding problems. And as someone with over 6 years of experience in machine learning, I really enjoy solving these, so thank you very much to the creators of this website. Okay, let's dive into this problem. So in calculate mean by row or column, we need to write a Python function that calculates the mean of a matrix either by row or by column, as it says, based on a given mode. So we're going to get this mode thing, which is a string. It's going to be either row or column, and this is how we know what we need to calculate. The matrix that we get is going to be a list of lists, and we need to return another list which only has these means. So for example, in this example, we have mode as a column, so the mean is going to be 1 plus 4 plus 7 divided by 3 elements. That gives us 4. And same 2, 5, 8, that's going to give us 5. So I think you can manage to get how we're going to calculate these means, and I'll show you also a really nice animation that I made that better illustrates this. But if you want to learn a bit more about this topic and get kind of a more formal definition, they have some really nice documentation here where they kind of break it down and show you how to solve each one of these. So if we take a look at what it means to calculate the mean by row or by column, so this is how we do it for column-wise. So as you can see, we're iterating over each column, summing up all the elements, and then we divide by the number of elements. And that's how we kind of get this mean, which we have up here. For rows, it's going to be the exact same thing. We're going to iterate over the different rows, sum all the elements up, and then divide by the number of elements to get the mean. Now, seems simple. Let's think how we can code this up. For rows, each one of these rows is a list. So we just need to pull these lists out of the matrix, take the sum, and then divide by the number of elements. Pretty easy, right? Now, stop and think for a sec. How would you do this for the columns? So we need to iterate somehow over the columns, even though the rows are the list that we actually get. Have any idea how to solve this? All right, let's jump into the code. We'll see how we can do this. So let's zoom in over here. Now, what we want to do is we're going to need for this calculation the number of columns that we have in the matrix. But since this is a list of lists, what we need to do is just look at the length of each row. And since all the rows have the same length, we just need to just pull out any row. So for example, the first one, this is how many columns we're going to have. And our output list, we'll start initializing it over here. And this is what we're going to fill up with the means. So if our mode, again, we only have 2 options, by row or by column. If it's for the row, like we said, this is pretty easy. We're just going to iterate through all the rows of the matrix. And the mean is given by the sum of the row divided by the number of elements in each row. And we just need to add this to our output list. That's it. Then we're done. So we'll do this for all the rows and we're done. However, for the columns, it's a little bit more tricky. So what we're going to do is we need to pull out each column from the matrix. So the way we do this is we iterate over all the rows of the matrix like we did before. And in each row, we only pull out the ith entry. So this is the index of the column. So we only pull out the element at index I from each row. So this is the ith column. And we do this for all the rows, and then we just get like a column that spans the entire height of the matrix, which is exactly what we want. And then the mean is given in the same way. So we just sum over all the values over here. And add it to our output list. That's it. So let's see if this runs. And it does. Very nice. So I had a little indentation error thing over here, which was a little bit annoying, but now it runs. Now we got this. This is how we do it by rows. This is how we do it by columns. We need to pull it out. That's the main lesson of this video. Another thing I want to go over is how can we do this in Numpy, because this is what you're actually going to be doing in real life. So import Numpy as NP. We're going to convert our matrix into an array over here. And now here's the tricky part. So this matrix is going to be of size number of columns of rows by number of columns, right? So if our matrix, if we need to do calculated by row, we want to get an output vector that is of size number of rows, right? The mean of each row. So in this case, how we do it in Numpy is we do .mean, and we need to say which axis we're going to take the mean over. So this is going to be the axis that's going to vanish because we're going to take the mean over this axis. So if we want something that the output is the number of rows, we're going to take the mean over the second axis, which is number of columns. And likewise for the up, if we want to do this by columns. So here the axis is going to be by number of rows, meaning we're going to average over this, and the output is going to be by size number of columns in this case. So this is where it gets a little bit confusing. But as you see, this is how we do this. So it's going to be much more clean after we fix it all up. And it's exactly the same. So here there's really no difference between rows and columns, and that's why the syntax is much better. It's going to run way faster. So before we finish, let's see that it actually runs, and we'll send it out the tests. And it does. It works just like before, but this is going to be much faster. So I hope you learned something today. This is really detailed way to do it also in Python and also in Numpy. And if you want to dive deeper in other operations which are used a lot in job interviews, I would recommend this Reshape a Matrix video, which we can find right here.